Okay, sine is 1 over what? Who's got that one down?
Cosecant.
1 over cosecant. Very good. 1 over the cosecant of theta. Good. Cosine is 1 over what? Secant theta. Awesome. You guys are rocking. And tangent is sine over cosine. Sine theta over the cosine of theta. Good. Beautiful work. Okay. I'm going to come back to that in just a second. Please give yourself a unit circle over here. Okay. There's a little unit circle. And what we're going to do in our unit circle is we're going to decorate our unit circle with some points. Okay. Some very sophisticated points. So let's put a circle in here. There it is, as best I can. Okay, there's a circle. So if I'm on the unit circle, what point does this represent straight out to the right? What point does that represent straight to the right? If I'm on the unit circle.
0 degrees.
What point in the coordinate plane? 1, 0. You guys agree with that? Okay, how about straight up? What would that be?
0, 1.
0, 1. Good. How about straight to the left? What would that be? -1, 0. Good. Awesome. Straight down? 0, -1. You guys are doing great. Okay, now let's fill in the appropriate radian measures for each of those, okay? So this would be 0 radians or 2 pi. What would straight up be? 90 degrees. Pi over 2. Thank you very much. Pi over 2. How about straight left? Pi radians. Very good. And straight down? 3 pi over 2, right? 90 degrees, 90 degrees, 90 degrees. So 1 pi over 2, 2 pi over 2, 3 pi over 2, and then finally back to 2 pi. Okay, let's also remind ourselves that if this is a coordinate in the plane, okay, x comma y, the x values deal with which trig function? Sine or cosine? X always deals with cosine, very good, and y always deals with sine. So I'll write those in case we forgot. X is always cosine, y is always sine. Okay, now, our goal out of this whole picture here is to come up with the domain for the sine, the cosine, and the tangent. So we have sine theta, cosine theta, and tangent theta. And what we want out of this from the picture is to develop the domain and the range for each one. The domain and the range. And the domain and the range. And we'll just focus on these 3 for right now. Sine, cosine, tangent, domain, and range. Okay, here's how I introduce this. Think of it like as this picture of the circle. Let's start with sine first. So am I looking at the x coordinate values or am I looking at the y coordinate values?
X.
Sine. Sine. Y coordinate values, okay? So can you name one spot on this unit circle that we have put in that has a y coordinate value?
0, 1.
0, 1. Can you give me another one?
0,
0, 1. Can you give me another one? 1, 0. Give me another one. How many did you just name? How many more are there?
Thousands.
Infinitely many more. That entire circle is filled in. There are infinitely many more, right? So I've basically just described the whole entire domain for the sine function since that entire circle is completely filled in. The domain for the sine function is all real numbers, okay? So some people go, well, the circle is only 1 unit big. I go, that's true. But could I make that circle 2 units big? And that circle would still be a circle. It'd just be bigger. And I can also shrink it down. So I can make that circle as large as I want or as small as I want. And I would still have a full circle. I would have an infinite amount of y coordinate points. Do you guys buy on that? Yeah. Right? It's not that abstract, right? Okay, take that same knowledge, take that same logic, and apply it to the x values. What would you think? What's the domain? All real numbers again. Exactly. The domain for your cosine functions, all real numbers, right? Every x value is filled in. Thank you so much, sir. Staple it and put it over there. It's over there. Okay, now, unfortunately, that trick does not work for the tangent function. You would think, well, since the domain of the sine is all real numbers and the domain of the cosine is all real numbers, and since the tangent is just sine over cosine, all real numbers divided by all real numbers, well, it must be all real numbers, right? Fortunately, it does not work, and there's a very fundamental reason why. I wonder if anybody sees it in this room. Olivia says you can't divide by 0. That's absolutely true. So the question I have for you, when is the cosine, which deals with x values, a value of 0? Daniel. Verticals. So at pi over 2 and at 3 pi over 2. You can't have a tangent there because you're dividing by a 0. Does that make sense? Yes. Okay, now, but what about this? Where's 5 pi over 2? 5 pi over 2 is coterminal with what?
90 degrees.
Which would be pi over 2. Right? Okay, what about 7 pi over 2? Where's that? That'd be down there. What about 9 pi over 2? Up top. What about 11 pi over 2?
So it's all odd.
That's what I'm getting at. Nice job, Daniel. We want all real numbers x such that x is not an odd multiple of pi over 2. Such as 1 pi over 2, 3 pi over 2, 5 pi over 2. And the reason is because you're dividing by 0, because the cosine value of all those functions are 0. So, calculator's out. Let me show you a little demonstration here. Turn it on. Let's clear all this stuff out. If I'm going to ask my calculator for a radian, what mode should I be in? I should be in radian. So go to mode and make sure you are in radian mode, please. Go to mode, make sure you're in radian mode. Okay, here we go. Let's ask the calculator, what is the tangent of pi over 2? What should the calculator say?
Undefined.
Go away. I don't like you. Yes. It says domain error, right? Domain error. I don't like you. Go away. I don't like that question, right? Okay, calculator, what's the tangent of, how about 3 pi over 2? Come on, calculator, help me out. Go away. Again, I still don't like you, right? Because we're dividing by 0, we're asking to the calculator to divide by 0. There's a domain error, so that explains why our domain is what it is for the tangent. You guys buying that? All right, cool. All right, great. Okay, the ranges of these functions, the range goes from -1 to +1 and everything in between for both sine and cosine, -1 to +1. And the range for the tangent function happens to be all real numbers. We're going to talk a lot more about these when we start graphing on tomorrow. Okay, so sine, cosine, tangent. We have the domain and the range. There's a great table in your book, so I'm going to make a reference to that right here. See the table on page, I don't know what page it's on. Chapter 7.5. Okay, there's a really good table that tells you all this good information. I just want to develop these 3 with you. All right? Because I want to move on to something else. I want to move on to even and odd functions. Okay, I don't know if you guys remember from algebra. If you evaluate f of negative x and you get back negative f of x, is that an even or an odd function? Take a guess. You're right. Yeah, odd functions, right? And if you evaluate f of negative x and you get back the positive f of x, that gives you an even function. Okay? The same idea works for sine, cosine, and tangent. If you take the sine of negative theta, you get back the negative sine of theta, which implies that the sine is an odd function. However, with cosine, it's a little bit different. If you take the cosine of negative theta, you end up getting back just the positive cosine of theta, which implies that cosine is an even function. I'll do tangent for you. Tangent negative theta is, what do you guys think? If you had to take sine divided by cosine, what would you think it would be? Positive or negative? Yeah, you got it. It's negative tangent of theta, which implies odd. Okay? What about the reciprocals? If the cosecant is 1 over the sine, do you think cosecant is odd or even? You got it. So the reciprocals also match up, okay? So the only even ones out there in the world are cosine and secant. Those are the only even ones. Okay, so let me give you one more little demonstration about this and to show you how it works. I want to go to degrees now. So let's go back to mode and put myself in degrees. Okay, and I'm going to ask the calculator for the sine of 30 degrees. Or excuse me, negative 30 degrees. What's the sine of negative 30 degrees? And notice it spits back negative 1/2. That's the same thing as the negative sine of 30 degrees. Notice that those two things are equal. So since the sine of negative 30 degrees is equal to the negative sine of 30 degrees, we have an odd function that does not work the same way for cosine. Cosine of negative 30 degrees gives me back, oh look, a positive answer, the same thing as the positive value of cosine 30 degrees. So that's why those two are what they are. Tangent works the same way. And really it has all it has to do with is where it is on the coordinate plane. Okay? If you have a point over here, and we'll call that point x comma y, this point down here is x comma negative y. So notice that the y is the only one that changed different. change value, right? And it works like that all the way around the coordinate plane. Okay, so I can see the yawning beginning of it, so I'm going to be done now. Even and odd functions, sine and tangent are both odd. Everything else is even. And the important idea is sine, cosine, tangent, the domains for those, and why those are what they are. I just wanted to shed some light on those, okay? All right, partner up with everybody. Partner up with